Welcome to Beyond the Microchip, brought to you by Microchip Technology. In part one of our two-part episode on microcontrollers, makers, and the DIY movement, we discussed with the Wizard of Make how the Arduino movement was born and Microchip's role in its enduring success. In part two, we continue our conversation and get into 8 versus 32-bit, warranties are meant to be broken, and the future of Microchip's collaboration with the maker movement. Thanks for listening. Let's go beyond the Microchip and hear a story of empowering innovation to enhance the human experience. I don't know if it was from Make Magazine or if it was just something that I ran into at a maker fair one time, but I remember seeing something along the lines of warranties are meant to be broken.
Yes.
Is that kind of the ethos of the DIY movement?
It is. It is. And another one, the ethos was I fix it, right?
Yeah.
Because trying to get away from the disposable, landfill polluting stuff, being, right to repair, being able to get in there and and fix that wire or yes, there was some like shady hacks, but that wasn't Arduino based, where someone broke the security code on the video streams, right? And someone published that algorithm on a t-shirt.
Any tool is going to have bad actors use it, but I mean, the general idea of my only option is to throw it away.
Yeah.
You can see where somebody that's good at their hands or they're very ingenuitive would like, I want to fix it.
Yes, absolutely. Absolutely. So that appealed to the next generation, that came from the guys that, and the women who custom, rebuilt cars or restored antique audio equipment or whatever, right? It's a thing, and it still is a thing. So, and it's still rolling. Now it's transitioning. If we go back to the specifics, a lot of it's transitioning to the 32, but the 32-bit. I'm going to get to that in a minute. But the other thing I want to talk about is the family of the AVRs, the 328P and the Mega 2560, and its brethren, and then its USB powered brothers and sisters, the 32U4 and the 16U2. We needed to adapt and make these chips a little bit more powerful. And the unfortunate byproduct of that is sometimes you have to break code compatibility. The core is the same, the compiler is the same, the instruction set's the same. But microcontrollers essentially are called microcontrollers rather than microprocessors because they control things and they interface to the real world. And that's where the UARTs and the timers come in. And we had to... There was some well-known bugs in some of the stuff, but people got around it. But in order to make parts more... The AVR, the newer generation... of AVRs, to make them faster and add more UARTs, we had to change the guts inside, which meant the code that was driving the UART on the 328 needed to change. So hence came the AVR DX family, the DA, the DB, the DD. We released the DU last year, which has
this is
USB.
where we're getting into AVR Core?
AVR Core. So AVR Core is a fork off of GitHub, and I want to get this attribution out very quickly, from a GitHub repository called DX Core that was created by Spence Conde, who's a brilliant young man out on the East Coast, MIT, of MIT pedigree. And we released these new parts right around, or the first one of these generations, right around COVID. So obviously that kind of prevented myself and Microchip in general to get the word out on this. Spence had been writing support for some of our new Ivrea Tinies and these new DX parts, which they're really good parts. But I forked AVR Core off of DX Core because Spence had gone and just wrote what we call the core libraries, which was all hidden from people that use Arduino. They use a thing called, pin mode to set a pin either in an or input or an output. Arduino had written all that hidden support themselves. Spence started out and rewrote the pin mode equivalent in the DX core, and then you load it into the Arduino ecosystem. Spence's DX core, he supported all the new chips and all the new pin packages. So it takes a while to configure it. I mean, it's completely universal and it completely supports everything. But on the other hand, it kind of stepped away from the walled garden approach. When you picked an Arduino Uno, it just worked.
Right.
With DX Core, again, lots of code, lots of support, lots of error checking, just an amazing amount of effort he put into it. But what would happen is when I was teaching and someone was using one of our new Curiosity Nanos that had one of the new parts on it, it would take a while to actually configure the system just to build against a Curiosity Nano board. So AVR Core is a fork of that, which I've made a walled garden and go, here's your choice. You got a DA, Curiosity Nano, a DB, or a DD. And I guarantee you, any code you write is going to work, right? So
was there any capability trade-offs?
There were a few. What I've done is I've de-scoped some of the really enhanced stuff, and I'm making some decisions now. Because if you make some of the new enhanced stuff too hard to use, people don't use it.
That's usually your trade-off, right? Is ease of use for capability.
Exactly. So I'm trying to, like I said, make it easier, but then referring back to here's a hidden function that you can use. It looks a lot like Spence's, but right now we just need to get people more used to using the new DX parts and the new EA part, the Ivrea EA parts along the way. And I want to make that experience as pleasant and as fault-free as possible.
Okay.
So that's Ivrea Core. Yep.
You mentioned a little bit earlier about 8 versus 32, and I know that there's multiple bit configurations coming through in microcontrollers, but there is still a place for 8-bit, right? There is still relevance?
Indeed. So the IoT, the growth of IoT really pushed 32-bit forward because the internet protocol stacks like TCP/IP and UDP, and again the networking stacks and the RF stacks really like 32 bits more, because for a myriad of reasons you just need that 32-bit width to deal with. But the 8-bit relevance, it's still relevant back to the original intent of Arduino when Massimo and Tom and Gianluca was the education. Learning microcontrollers is a lot easier when you start with 8 bits.
Yeah.
It's easier to get your head around the architecture and the way the bits work, and you start counting binary because you get that foundation set, and then you can move to 32 bits a lot easier. Diving into 32 bits microcontrollers, and that's still a heavy lift for everybody that's making microcontrollers.
Like learning how to parallel park in San Francisco?
Yes, very, very good analogy, because not only are you dealing with 3 more bytes, you're dealing with peripherals that are just a lot more complex. Because they go, hey, we got the 32 bits now, whereas like even the GPIO ports on an 8-bit machine might have 3 to 7 register, things you got to write to, and including some of ours. There's like 25 registers that you got to twiddle. Which ones do I leave alone? Which ones do I have to set to actually get an LED to turn on? Right. And it's just there's just so much there that the 8-bit space is still very relevant in education. I can, when I'm entered high schools or teach classes, I don't dig down too much into the details sometimes, but it's a lot easier just to draw an 8-bit register and go, if there's a 1 here, that means your LED's on.
Well, if we're looking at a dearth of engineers coming up in the next few years or within the next decade, and you have something that's nice, accessible, easy to understand, the last thing you want to do is frustrate somebody just starting out, right?
Yeah. It comes back to that. You heard about the 5-minute UBI, right? The out-of-box experience.
Yep.
Arduino has 32-bit support. They've had it for quite a while. We actually enjoy quite a bit of 32-bit presence in the Arduino space with the SAM microcontrollers. It's one of Adafruit's favorite 32 bits, the SAM D51, because they ported MicroPython. Well, they called it CircuitPython. They've got that running on it. It has its place. And then again, in terms of complexity, if you're not doing a whole bunch of really gnarly IoT stuff, if you're basically flushing a toilet or operating a toaster or something like that, 8 bits are perfectly fine, right? LED blinkers, right?
Yeah, purpose-built, right?
Purpose-built, not connected to anything. And again, kind of unfortunately rotating back to that disposable electronics thing, but typically a toaster, or toast oven, typically the element burns out, or the button stick or something like that. The microcontroller's just sitting there happy. I just replaced our built-in microwave oven, and it's the Magnetron. They have limited lifetimes, so the microcontroller was fine. So yeah. So that's, again, there's still 8-bit. There's 8-bit relevance out there, and especially what I'm focusing on, just the ease of use. I mean, Arduino makes it real easy, but to teach people how to dig down deeper, the 8-bit stuff makes it much easier to cover things or to go over the concepts.
So as we're wrapping up, what do you think the AVR core roadmap looks like?
So my next big lift absolutely is getting the AVR DU, which is the USB one, supported. That USB part, and I'll be perfectly honest, has been a long time coming. And there's still, as I track Microchip makes and the media channels that Microchip follows and or publishes, and the other social media channels I follow, I still see a lot of which is fine, which is great, 32U4 and 16U2 projects, because people just want, I'm going to make this stupid thing, not stupid, I shouldn't, this interesting project, and I'll get back to that. This interesting project where I made a keyboard out of squishy balls or something like that, and then they want to be able to plug it into a PC and make it look like a keyboard. And that's an HID device. The AVR DU is a less expensive, higher performing, less expensive to implement substitution or upgrade to the 32U4. But the key killer thing on that is I need to get the USB stack working for this part in the Arduino environment. We have some other parts coming up. We released the AVR DA, and I don't want to turn this into a whole ad for the new parts. The EA will come along. There is, I need to wholly upgrade the C compiler. We're at GCC 7.3. Current one, I think, is GCC 14, and people go, why are you so out of date? Embedded compiler generation for 8-bit cores like the AVR, there's a limited return on investment for optimization because people aren't focusing on it, and sometimes you just reach the end of the road. You can only make a compiler so efficient. But there are some other features that are nice to have now that we need to incorporate, because most of the GCC stuff right now is focusing on the 64-bit ARM stuff. So there's a lot of features in the new GCC compilers that we'll never need in the code generation. And as well, when you're doing with embedded, you really want to test stuff. You want to make sure that that compiler's safe, because yes, an LED blinker is one thing, but part of an engine control unit or a body thing in a car, you want to make sure that that compiler is generating the right code, right?
It's got to be reliable. Yeah,
it's got to be reliable. People's lives are on the line, in some cases. So the DII, the USB stack, the compiler uplift. There's some other tweaks around the compiler, the build system. And I'm Arduino and I are in air quotes violent agreement on homogenizing the GCC compiler build, because, and then along with Spence, because we're all building our own versions of GCC, which is what it's meant to do. But there's some other things where Microchip provides what we call the device packs, the specific header files to describe these parts, to make that easier to roll in. So the DU, and then I'm going to start bringing in the 32-bit Curiosity Nanos. Again, there's Arduino has a lot of 32-bit boards that use our technology, but we have Curiosity Nanos that use our legacy 32-bit parts, and now and our newer parts. And I'm going to lean heavily on both Arduino and Adafruit libraries to, again, define our Curiosity Nano parts in the 32-bit space. So then probably next year sometime, there's going to be Aviar core, and then there's going to be ARM core. So that's the roadmap for now.
As we do on most of these episodes, we kind of want to close out our discussion with a prediction. Now, we're not holding you to it. We're not going to come back and visit you to see how well you did. A prediction is really just to get people thinking and to ask questions. So if you look back on the last 20 years of the maker movement, what do you see for the next 10 or 20? What could the future look like for this movement and the direction it's going?
So I think it's easy to say that the maker movement, the complexity of the projects is going to increase because the complexity of the chips is going to increase. But a key enabler of that is how the makerspace is going to embrace AI, because AI is, everybody's mentioning AI. So are you going to get AI to write your code for you? AI still has, it's not quite there yet in making embedded code. AI loves Python or any of the higher scripting languages. So the complexity of the projects, I think, is easy to say. But I think that I would like to see, in air quotes, that the AI aspect of it allows people to be more creative and push their boundaries a little bit and rely on AI to write the code, or at least come up with the algorithms to write the code. And it's going to largely track, again, as the 32 bits get bigger and bigger. The limiting factor, hopefully, isn't the ability for people to be able to get a hold of these systems or develop their own systems, their own, design their own circuit boards or things like that. We're coming on to a return on investment thing right now, which hopefully, again, AI will help solve, because we're getting, again, the complexity curve is, just as anything in high tech does, is exponentially rising. So I really hope that the makerspace will tamp that down or moderate that a bit. I'm not saying, like slow it down. I'm just saying that they'll adopt it on their own, at their own pace. I think that as they brought back Maker Faire post COVID, and we're having another one in Mare Island. And just the increase from, there was a dead zone where Maker Faire had to shut down the two big ones, San Mateo, New York. But there's a huge attendance increase last year, and we're hoping for another step increase. So it's going to grow. Maybe it'll curve out. I hope not. But yeah, it's It's how AI is going to help people along in this increasingly complex world, because, NVIDIA is making a bunch of noise with all their AI and stuff like that. But at the end of the day, it has to stay accessible by the makers, right? So I'm predicting a lot more AI influenced stuff, whether directly code generation or just making people's dragon wings for costumes a lot more elegant, right? So
I think that's a great prediction for us to close out on, Bob. Appreciate your time today. Thanks for joining us.
Absolutely. It's a great discussing one of my passions.
Bob Martin is affectionately known as the Wizard of Make here at Microchip Technology. He joins us today from his home office in Northern California. Thank you for venturing beyond the microchip with us. Join us next time as we continue to explore empowering innovation to enhance the human experience.